In this video we'll talk about simplifying exponential expressions in general. Now it's good to know what's meant by simplify. So an exponential expression is considered simplified when the following conditions are met. First of all, each base should occur only one time. For example, if we have x's in the top and x's in the bottom, that means that more simplifying can be done. No parentheses should appear, and no powers should be left raised to powers. Now usually we use parentheses to notate when powers are raised to powers anyway, so these two kind of go together, but you should always simplify until the parentheses are gone. There should be no powers left raised to powers, and we should not have any negative exponents because they should be written as positives. There should not be any zero exponents, and any exponents of 1 should not be written. Now let's work on a few examples together. And as we go along, I'll try to give you a couple of tips of how I try to approach these problems. So 20x squared over 15x to the 9th, we see that we have 20 over 15, which is a fraction that can be reduced. Now 20 divided by 15 will leave us with 4 divided by 3 because 5 goes into both of these numbers. Now our quotient rule says we subtract the top exponent minus the bottom, so 2 minus 9 is negative 7. And then we know that we can't leave any exponents negative, so we will move that x to the bottom, and we have 4 over 3x to the 7th. Now that is the way that your textbook probably does it. Most textbooks do it that way. But I have another way I would like for you to think of this. You can still go ahead and think of the 20 over 15 as a fraction that can be simplified, so that'll make 4 over 3. But now think of it this way. X squared really means x times x. And x to the 9th really means 9 of these. Now, we know that every top and bottom pair of x's will cancel out. So, where are the leftover x's and how many are there? There are 7 x's left over, and of course they were in the bottom because there were more x's in the bottom when we started than there were in the top. So I visualize 9 in the bottom, 2 in the top, and I know that after they're done canceling there are 7 leftovers and they're in the bottom. So x to the 7th. And if you'll think of it that way, you really don't usually have to encounter that negative exponent rule. So we may see that again on part B. Let's go ahead and look at part B together. Now I notice that part B has a negative exponent outside and it has all this stuff inside. And you could, if you wanted to, start with this negative 2 and use the quotients to powers rule to apply the negative 2 exponent to everything. And if you do, it is not wrong to do it, but it is incredibly complicated. So what I recommend to you is make sure that you simplify inside the parentheses first every single time you start one of these problems. So if we simplify first, then 6 divided by 2 simplifies to 3. I have 7 x's in the top and 11 in the bottom. That means there are 4 extra ones in the bottom, so I'll have 3 over x to the 4th. Now it's all to the negative 2. Now we learned in the negative exponent lesson that when we have a negative exponent applying to a fraction, it flips the fraction over. So I've used up the negative part of the exponent by flipping this over. Now I have to do the second power to the top and the second power to the bottom. X to the 4th to the 2nd is x to the 8th, and on the bottom 3 to the 2nd power is 9. Okay, part C, 3x to the 3rd times 5x to the 14th over 20x to the 14th. I think I might combine this top together first. 3 times 5 is 15, and x to the 3rd times x to the 14th is x to the 17th. Then you've still got 20x to the 14th in the bottom. Now 15 over 14 reduces because both of those numbers can be divided by 5. Reduces to 3/4, and x to the 17th over x to the 14th. I have 3 extra x's in the top, so I'll have x to the 3rd in the top. Now let's do a few more together, and I hope that you will pause the video and work these on your own before you watch the solutions. Okay, so let's get started. We see here that we have a complicated fraction inside these parentheses. So before I start, I would like to simplify here. 4 over 2 will reduce to 2. And x to the 5th over x to the 2nd reduces to x to the 3rd. See, the 5 is larger than the 2, so 5 minus 2 is 3, and it goes in the top. Now, the whole thing is to the negative 4. If you like, you can think of 2x to the 3rd as having a denominator of 1. And then you can say, okay, a negative exponent will cause the fraction to flip over and will make the exponent positive on the outside. Now we have to do the 4th power to everything in the parentheses. So 2 to the 4th is 16, and x to the 3rd to the 4th is x to the 12th. Now in part B, you see that I have a negative exponent in the denominator. So I would never start on a problem while I can see negative exponents. I want to make them all positive before I start. So I'm going to move this y to the negative 5th up into the top where it can be positive. Now of course that gets rid of my denominator, but that's perfectly okay. And now we have 6y to the 4th all raised to the 3rd times y to the 5th. And I'll do the 3rd power to everything in these parentheses. I'll have 6 to the 3rd, y to the 4th to the 3rd times y to the 5th. Now y to the 4th to the 3rd, that's a power rule problem, so that will make y to the 12th. 6 to the 3rd is 6 times 6 times 6, which makes 216. Y to the 4th to the 3rd is y to the 12th, and then it's times y to the 5th. And now you can see that the y's are both in the top. So we need to add those together. They're not going to cancel because they're not top and bottom. But we have 12 y's and 5 more y's, which makes 216 y to the 17th. Now when you look at part C, you see that I have another negative exponent, so before I start, I will write this in positive exponent form. And then I have the 4th power of 2y to the 3rd, and it's over y to the 6th, so I have to do the 4th power of everything in the top. And y to the 3rd to the 4th is y to the 12th, 2 to the 4th is 16. And now look, I have 12 y's in the top, 6 y's in the bottom, so these 6 down here are going to cancel 6 of the ones here, and that's going to leave 16 y to the 6th.